So here we have the function sine of x squared plus 1. So we need to find its derivative with respect to x. So the trick here is we are going to assume that x squared plus 1 is x. This is just an assumption that we are going to imagine that if it were equals to x, then we would have the derivative of sine x would be simply cosine of x. Now x here is x squared plus 1. Now this is the assumption that we have taken, that x is equivalent to x squared plus 1. So we need to find its derivative and multiply it to cos x squared plus 1. So this is called the chain rule. So we have cosine of x squared plus 1, and the derivative of x squared will be twice x plus derivative of 1, which is 0. So our final answer is twice x times cosine of x squared plus 1. So let us do another problem. So here we have the function e raised to the power of sine of x. So we need to find its derivative with respect to x. Now we know that the derivative of the exponential function gives us the function itself. Now here x is represented by sine of x. So what we're going to do, we're going to assume that the sine of x is actually x. If it were the case, then it would give us e raised to the power of sine x, which is the function itself. However, sine x we have assumed by ourselves to be equals to x, so we're going to multiply it to the derivative of the assumption, which is sine of x. So the derivative of the sine function is cosine of x, and this will be multiplied to e raised to the power of sine x. So this is the answer. So let us do another problem. So here we have log of sine x. So let's try to find out its derivative using the chain rule. So we will use the derivative of log of x is 1 over x. Now here instead of x we have sine of x. So if we assume that sine of x is equivalent to x, then the formula derivative of log of x will give us 1 over x. So x here is sine of x. But since this is an assumption, we have to multiply it to the derivative of sine x. So sine of x is cosine of x. So we have cosine of x over sine of x. Now that is equals to the cot of x. So this is the derivative of log of sine x. Let us go and do another problem. So here we have the function log of sine x squared. So we are going to apply first the derivative of log of x by assuming sine of x squared is equivalent to x. So that would give us 1 over x. So our x here is sine x squared. So that means we need to multiply it to the derivative of the assumption of the assumed value, which is sine x squared. Now we find out the value of the derivative of sine x squared. We have sine x squared. Now then again we have sine x squared here instead of x. So again we're going to assume that x squared is equivalent to x. So that means we will have derivative of sine x, which is cosine of x. So x here is x squared. Now then we have made an assumption that x squared is equivalent to x. So that means we have to again multiply it to the derivative of x squared. So this is called the chain rule. Now cosine x squared over sine x squared times derivative of x squared will be twice of x. So that gives us twice of x multiplied to the ratio cosine x squared over sine x squared is simply the cot of x squared. So this is the derivative of the given function, which is log of sine x squared. Let's move on to the next question. So here we have the exponential function e raised to the power of sine x squared. So let's find its derivative with respect to x. So here we can assume that sine x squared is equivalent to x, then that we'll have sine x squared that can be assumed to be equals to e raised to the power of x. And we know that the derivative of the exponential function gives us the function itself. So derivative of e raised to the power of sine x squared is going to give us e raised to the power of sine x squared. Now we multiply it to the derivative of the assumed value, which is sine x squared. So we have derivative of sine x squared. Now again we are going to assume that x squared is equivalent to x, so that sine x squared can be thought of to be equivalent to sine x. So that means we will have derivative of sine x, which is cosine of x. So x here is given by x squared times the derivative of x squared. So the final answer will be e raised to the power of sine x squared times cosine of x squared times derivative of x squared, which gives us twice of x. So let us do another problem. So here we have sine of e raised to the power of x squared. So let's find the derivative. So we're going to assume that ex squared is equivalent to x. So that means we should get cosine of x, which is the derivative of the sine function. We'll have cosine of e raised to the power x squared, which we have assumed is actually equals to x, times the derivative of our assumption, which is e raised to the power of x squared. So we have cosine of e raised to the power of x squared multiplied to, now we have the exponent function, derivative of the exponent function, e raised to the power of x squared. So we should get e raised to the power of x squared, the function itself, multiplied by the assumption that x squared is equals to x. So we find the derivative of x squared. So our final answer will be cosine of e raised to the power of x squared times e raised to the power of x squared times derivative of x squared, which is twice of x. So let us move on to the next question. So here we have x squared plus x plus 1 raised to the power of 4. So let's find its derivative with respect to x. So here we are going to assume that x squared plus x plus 1 is equivalent to x. Then we can apply the power rule here. So we have the power rule, d over dx times x raised to the power of n gives us nx raised to the power of n minus 1. So here n is 4. So we have 4 times x squared plus x plus 1 raised to the power of 4 minus 1 multiplied to the derivative of the assumption that x squared plus x plus 1. So we have 4 times x squared plus x plus 1 whole cube times derivative of x squared is twice x plus derivative of x, which is 1, and derivative of 1 is 0. So we can multiply 4 to 2x plus 1. We have 8x plus 4 multiplied to x squared plus x plus 1 whole cube. So this is the derivative of the given function. Let's move on to the next question. So we have x squared plus x plus 1 raised to the power of half. So we need to find its derivative with respect to x. So we're going to use the power rule by assuming that x squared plus x plus 1 is equivalent to x. So that should give us half multiplied to x squared plus x plus 1 raised to the power of half minus 1 times the derivative of our assumption, which is x squared plus x plus 1. So we find its derivative. So that should give us half times x squared plus x plus 1 raised to the power of half minus 1, which is negative half, times the derivative of x squared plus x plus 1 should give us twice x, which is the derivative of x squared plus derivative of x, which is 1, and derivative of 1 is 0. So we have 2x plus 1 over 2. Then if we take the function x squared plus x plus 1 raised to the power of negative half to the denominator, we have x squared plus x plus 1 raised to the power of positive half. Or in other words, we can rewrite it as 2x plus 1 over 2 times the square root of x squared plus x plus 1. Let's move on to the next question. So here we have sine cube x. So let's try to find out its derivative with respect to x. Now sine cube x can be also rewritten as sine x whole cubed. Now this has been done so that if we assume that sine x is equivalent to x, then we'll get the form of derivative of x raised to the power of n, and then we can apply the power rule to give us nx raised to the power of n minus 1. So this should give us 3 times x, which is sine of x, raised to the power of 3 minus 1 times derivative of our assumption, which is sine x. So that gives us 3 times sine x whole squared multiplied to derivative of the sine function, which is cosine of x. So we have 3 times sine squared x multiplied to cosine of x. So this is the derivative of sine cube x. So let's move on to the next question. So we need to find the derivative of the given function by applying the chain rule. So before that, what we are going to do, we are going to simplify the given expression. So we have the derivative of 1 over the square root can be converted to a radical form. So we have a squared minus x squared raised to the power of half. Now we're going to take it to the numerator, so that should give us the derivative of a squared minus x squared raised to the power of negative half. Now here we can assume that a squared minus x squared is equivalent to x, so that we can apply the power rule, which will give us negative half times a squared minus x squared raised to the power of negative half minus 1 times the derivative of a squared minus x squared, because we have assumed a squared minus x squared to be equivalent to x in order to apply the standard derivative rules. So we have negative half times a squared minus x squared raised to the power of negative 3 over 2 times derivative of a squared with respect to x minus derivative of x squared with respect to x. So we have negative 1 over 2. So we're going to take a squared minus x squared raised to the power of negative 3 over 2 to the denominator, so that we have a positive exponent. So plus 3 over 2 times we have derivative of a squared, which is a constant, so that will be 0. So we're left with negative derivative of x squared, which is negative 2x. So the 2 and 2 gets cancelled, negative 1 and negative gets multiplied to give us a positive. So the derivative of this particular function is equals to x over a squared minus x squared raised to the power of 3 over 2.